Fuel Subsystems, Chapter 19. In this chapter, you'll be able to identify fuel subsystem components on truck or bus chassis, describe components used in diesel engine fuel subsystems, and define the function of internal and external fuel tank components. Troubleshoot a fuel sending unit, define the role of primary and secondary fuel filters, service primary and secondary fuel lines, describe 3 ways water can be suspended in fuel, and explain how water separators function and service a water separator. Define the principles of operation of a transfer charge pump, prime a fuel subsystem, test the low pressure side of a fuel subsystem for inlet restriction, test the charge side of a fuel subsystem for charge pressure, and identify some typical sensors used in diesel fuel subsystems. Diesel fuel subsystem on a commercial vehicle is best defined as a group of components responsible for storing fuel and transferring it to the injection pumping apparatus. Although injection pumping mechanism can differ greatly from manufacturer to manufacturer, the fuel subsystems that supply them tend to have much in common. If you look at common fuel systems, you'll observe a clear divide between low pressure side and the charge side of the fuel subsystem. The fuel transfer pump divides 2 sections. Most of the fuel subsystems of this type and term suction, low pressure side, and charging circuit, high pressure side. Do not confuse with injection pressures, which are way higher than that, and are commonly used to describe both. We're going to go to this drawing here, which is a bit more intuitive. I'm going to turn off the camera off so you can see the whole system. The blue system that we see coming in here on the bottom right, the blue is the suction side. It's vacuum. It's measured in inches of mercury, and it's showing it going through the primary water separating fuel filter first. Then it shows it going through a divider, or what's also known as a junction block, and the blue follows up to the priming pump. In this fuel system, it goes down to the fuel pump or lift pump, and then it gets pressurized to about 60 to 80 psi, and it goes up into a filter unit. There's a stage filters here, and then the moderate pressure goes into the high pressure fuel pumps, and the high pressure fuel here is brown, and it's showing feeding each injector through a high pressure common rail. And then we see the yellow, which is a fuel return line, and that turns into pink because it's taking fuel return from the unit pumps, putting it back into the system, and then it goes out into a return line into the tank. So it's pretty straightforward. We have the blue, which is the suction side, and then we have the suction side right up to the fuel pump or lift pump, depending upon the engine. The green is going to be low pressure coming out, low pressure to the unit pumps. The unit pumps, these are cam driven on our engines, and the brown that you see up here feeding the injectors is high pressure. That's going to be well over 30,000 psi. We have a return from the injectors. The excess fuel is returned, and it combines with the return from the unit pumps and goes back into the system, and ultimately will return back to the tank. It's pretty straightforward. In highway tractors, fuel stored in fuel tanks. Most highway trucks' fuel tanks are mounted on the frame. It's common to use a pair of fuel tanks. This balances the weight of the fuel. They're located in an airflow. They're cylindrically shaped, aluminum in construction. Aluminum is less susceptible than steel to corrosion. It's much lighter, and it's best that they're maintained in 25% full or greater. Here we have a pair of tanks that show all of the components, but we have what's called a crossover or a supply line here but it's also called a crossover hose or tube that both tanks will be picking up fuel. They can't be switched to one or the other or both, depending upon the way the OE sets up the vehicle. Most heavy highway trucks use multiple tanks, usually two, to increase onboard fuel capacity, also to distribute the fuel weight evenly. Each tank requires a cap, and each tank must be filled separately when no crossover pipe is used, but typically most of our highway tractors will have crossover pipes or crossover tubes utilized. Most medium and heavy duty commercial truck fuel systems use remote from the tank fuel transfer pumps and not assemblies that incorporate an sending unit or the transfer pump. Variable resistance type of sending unit problems can be diagnosed by disconnecting the terminals and utilizing your digital multimeter in resistance ohms. That is, you have to check with the manufacturer specification for the minimum and maximum resistance and test your unit to make sure it is within your sending unit and make sure it's within the range. Most jurisdictions in North America permit venting of tanks to the atmosphere. A plugged fuel tank will rapidly shut down an engine, creating a suction side inlet restriction value to the transfer pump, and it will not be capable of overcoming and pump through that restriction. OEMs recommend a defective fuel tank be replaced rather than repaired. There are some recommendations for welding, but it's not really common in the average shop. Usually specialty welding shops would perform that. When evacuating tanks, check with the OEM for safe vacuum test value. High vacuum value may collapse a fuel tank. As a rule, cylindrical tanks will withstand higher vacuum test values than any square section tanks. Diesel fuel injection equipment is manufactured with minute clearances and impurities in the fuel, and if not removed by the fuel subsystem, can cause premature failures. Typical fuel subsystem with a primary circuit and a secondary circuit in most cases uses a two-filter arrangement, one in each circuit. Here we have a typical water separating fuel filter that has the whiff sensor WIF in the bottom. That's going to be in the suction side, and they're going to have a variety of different filtering capacities, but they're typically going to be in the neighborhood of 30 microns of filtration. Okay, fuel filters are rated by their ability to entrap particulates. They function on a fishnet principle, whereby particulates smaller than a certain size will pass through the mesh. Those that are too large will get entrapped in the filter media. Okay, this is a description of the size of a micron compared to the size of a human hair. The average human hair is about 3/1000ths in diameter. Primary filters are the first stage in filtration. They're usually less than atmospheric pressure, meaning a slight vacuum or suction. They're going to be designed to trap particles from 10 to 30 microns. It uses media ranges from cotton threaded fiber, synthetic fiber threads, and resin impregnated paper. Secondary filters are the second stage of filtration. They're typically charged by a transfer pump, so they're going to be under pressure. And they will typically trap particulate from 1 micron to 2 to 5 microns are also common. Water in its free or emulsified state cannot be pumped through most secondary fuel filters with nominal ratings of 5 microns or less. Testing charge pressure downstream from the charger and transfer pump is normally performed with an accurate fluid flow measure gauge plumbed in series between the transfer pump and the injection pump apparatus. That has been replaced by utilizing a component that clips into the quick release into the fuel system and will give you a reading on your multimeter, either in pressure for your secondary side or vacuum in your primary side. Testing low pressure side, primary filters under suction are tested with negative pressure gauge calibrated in inches of mercury. Inches of mercury calibration, negative pressure gauge should be connected in the circuit between the filter mounting pad and the transfer pump, so it's under vacuum. Actual inlet pressures vary considerably to fuel systems, and specifications need to be referenced from the service literature provided by the OE. Many EPA post '07 and 10 certified engines charging pressures may be much higher than their predecessors. This is because the charge side of the fuel system may be used to supply diesel particulate filter dosing injectors, which often require higher pressures. Check specifications and exercise caution. Procedures for servicing spin-on filter cartridges. Much dirt is placed in the fuel system by technicians using improper service techniques. Cummins has a clean care kit that is utilized when you open up the fuel system to make sure that you're utilizing the contact cleaner that they specify and the variety of plastic caps to seal the system as you work. After the primary filters have been primed and installed, secondary filters should be installed dry and primed with a hand primer pump or inline electric primer pump if equipped. You remove the old filter cartridge, you drain the fuel into a disposal container and ensure that the old filter cartridge gaskets have been removed. You'll have gaskets and O-rings, so you have to pay attention to detail here. You fill the new filter cartridge with clean, filtered fuel poured carefully into the inlet portion of the filter. The fuel itself is provided the gasket or O-ring and mounting threads with adequate lubricant. You screw the filter on clockwise, right-hand threads are used onto the mounting pad. When a hand primer pump is fitted into the fuel subsystem, externally prime only the primary pump, ensuring that the fuel is poured into the inlet side only. Install the secondary fuel filter dry and prime using the hand primer pump, and when electric primer pump is fitted into the circuit, you're going to utilize that. Removing filter cartridges, ensure the gasket is removed with the old filter. Common source of air induction, or what's called a vacuum leak or pressure leak double gasketing, will usually result in producing a substantial leak in the secondary filter. Water separators. Water separating fuel filters are common in practically every application. Often the water separator will combine the primary fuel filter and water separating mechanism into a single canister. The water separating mechanism is typically ends up at the bottom section of the primary fuel filter, and it will have a water and fuel whiff sensor there to set an alarm if water is detected. Water appears in three forms: free state, emulsified, and semi-absorbed. Emulsified water appears in small droplets. They can be suspended sometime in the fuel before gravity and centrifugal force takes them to the bottom of the tank. Semi-absorbed water is usually found in water solution with alcohol, a direct result of methyl hydrate. That's the type of alcohol added to fuel tanks as deicer or fuel conditioners. When semi-absorbed in diesel fuel, its most dangerous form, it can emulsify in the fuel injection system and cause serious damage to components. With the small micron filtration in the secondaries, it will typically clog the secondary fuel filter and shut the system down completely. So usually water doesn't get that far because the high pressure common rail systems are not going to allow water past the secondary filter. Free state emulsified is coalesced into large droplets. Some water separators use a centrifuge to help separate the larger globules of water and emulsified water from the fuel, so it's going to spin it and utilize centrifugal force and gravity. That information is asked in several of your test questions. Centrifuge subjects pass fuel through the centrifugal force, throwing the heavier water into the sump walls where gravity can pull them into the sump drain. Aluminum alloy cylindrical fuel tanks located in airflow in a truck acts as heat exchangers. Most trucks use dual fuel tanks mounted on both sides of the chassis. Most diesel fuel tanks are vented to the atmosphere. Many current secondary fuel filters will plug on water and shut down the engine. That is the content of several test questions. Water may be found in fuel in three forms: free state, emulsified, and semi-absorbed. Many fuel subsystems are equipped with water separating fuel filters designed to remove free state and emulsified water from the fuel. The WIF, water in fuel sensor, will signal water built up in a water separator or primary filter, and it will send a fault code to the ECM, and that will appear on the dash for the driver to see. Fuel system inlet restriction valves are tested on the suction side of the fuel subsystem using a mercury manometer, or typically the bypass a gauge that uses a quick coupler and converts your reading for your multimeter. So that has been modernized for most shops doing fuel work. Common source of air ingestion in a fuel subsystem is double gasketing of a filter under suction, so that the technician has to be careful that they remove all the gaskets and O-rings from that mounting flange that the fuel filter spins onto. Two types of fuel heaters are used: electric and heat exchanger types. Diesel fuel systems commonly use two different types of fuel transfer charge pumps, reciprocating plungers, and gear pumps. Both use a positive displacement pumping principle. Some fuel subsystems are equipped with a hand primer pump. The function of a hand primer pump is to purge air from the fuel subsystem. Technicians should prime secondary filters after installation using a hand or electric priming pump. Many current fuel subsystems use low-pressure fuel management module to reduce the amount of external plumbing and sensor wiring. An alternative to make multi-function fuel canisters such as Diesel Pro.